Hello, everybody. Welcome to lesson 11. So we are on unit number 2 now. We are starting algebra. Now, algebra, letters, numbers, I know sometimes it can feel like it's going to be an overwhelming unit or idea, but for me personally, these next 2 units, algebra, moving into linear relationships, I find are actually the most enjoyable um, problems to solve, just because for me, they're concrete and the steps are clear and the rules are precise. So for me, it's just a matter of following steps and finding the solution. So let's get started. We're going to talk about algebraic modeling. First off, we're going to talk about what is a variable. So we will read this definition together. A variable is a letter that represents an unknown or changing number. Variables must always be clearly defined. So a variable is always these 3 things. It's a letter, it represents a number, and it can change. A variable is always those 3 things. Now there's some examples. We see letters there. So when we talk about a variable, we always say let the letter represent something. So let M represent a number of movies rented. Let H represent number of hours worked. Let N represent a number of students. Those are just examples of variables. So those variables, M, H, N, those are just examples of what you could look at. Now, algebra uses words and letters to communicate information. A number in algebra usually is referred to as the letter N. What can some equations look like with N? 5 more than a number will turn into the expression N plus 5. So we're here, N plus 5. We can solve that, and we just need to decide on a number. So let's say our number is 2. Let's make N 2. So now we have to put that number N into our equation. N plus 5. So 2 plus 5 is 7. And that's with N being 2. With N being 2 over here, 3 times a number, we have 3 times N. So that changes to 3. And then we put in our number, 2. And that is 6. Over here on the side, there's a little note saying the definition of a term. A term is a number and a variable together. That makes a term. It always follows the number times the variable. So 2n, 3n, that is a term. That over there is a term. So this part of the handout, this is just showing us algebra in the sense of like how letters and numbers are interacting and how they're communicating with each other in an expression. Now, if we look at that top there, 10 less than a number. If we keep with n being 2, then our expression turns into 2 take away 10, which turns into -8. Here's a little word problem. Let's talk movies. So a movie streaming service, we all love a good movie streaming service. So this one is charging $12 a month per month and $3 per movie rented. What is the variable here? Is it the month or is it the movie? Which one is the variable? Now, we have to think, which one is changing? Which one is changing? The movie. The month, that is fixed. That's a fixed cost. That does not change. It's $12 per month. Now, our movie, that amount will be changing. Because someone could rent one movie, someone could rent 10 movies, someone can rent 20 movies. It depends. So we're going to say let M. Now, this is important too. When you're talking about a variable, you always use the word let. Let M represent something. Let M represent the number of movies rented. M stands for movies. That changes into this expression then. So the cost of this whole movie streaming service turns into 12 plus 3M. 12 represents the cost per month. That doesn't change. You're paying the $12 flat per month, plus $3 per movie you rent. So this expression models the fixed and changing cost. If someone rents 5 movies, how much are they paying? So then it's a matter of just using our expression and plugging in the information. So cost 12 plus 3, and they rented 5 movies. Let's solve that. 12 plus 15. 12 plus 15 is 27. So they pay $27. Now imagine they rent any number of movies. Why is it useful to use a variable? That is our question. Our answer is it's useful because the number of movies can change. And the variable lets us model any number. We will write that in a sentence. Because the number of movies can change, the variable lets us model any number of movies. And our second question says, what could the variable represent? The variable represents any number of movies. Really, the variable can represent any changing quantity. So we talked about variables. We talked about how letters and numbers are interacting, plugging in information. Let's look at 2 scenarios together. We're going to look at a gym membership and a babysitting job. So scenario 1, gym membership. A gym charges $25 membership fee and $8 per fitness class. Now, if we think back to the example we just did, one is a fixed cost, one is a changing cost. Our changing cost is the variable. So let's define a variable. So we have let C represent our fitness class. Right? $25 is our fixed cost, and this is changing. So the changing one is our variable. Now we will write an expression. So our total cost will be the $25 plus $8 per class. Explain how your expression represents this situation. So now in a sentence, just using our words, we're going to just write down what I just said. 25 represents the fixed cost of the membership. And 8C represents the changing cost based on how many classes are taken. So you're just explaining how we put together that expression and what that expression represents in words. Scenario number 2, a babysitter earns $15 per hour. Let's define a variable. So, do we have a fixed cost here? No, we don't. We only have a variable. We only have a cost per hour. So she can or he can work however many hours and get charged $15 per hour. So let H equal our number of hours worked. And then we will write our expression. Our expression will be our earnings will be based on our number of hours. So 15 times H. $15 times the number of hours worked. How much would they earn in 6 hours? So we know our H here is 6. We want to find how much she earns. So this is our expression. So $15 times 6 hours is 90. So the babysitter will earn $90 for working 6 hours. And that is it. That brings us to the end of this algebra lesson. Just talking about variables, we talked about how we can turn a variable into an expression based on some information. So now you're going to go work on your student handout and continuing practicing this idea of variables and letters and numbers. And I'll see you next lesson.